In today's lecture, we are going to go over fractions. Now, some of you are really good with fractions, so this section is going to be an easy section for you. Some of you might have difficulty with fractions, but what's important is most of you will have to teach fractions to your students. So please read these paragraphs on your own and get a general idea of why fractions are important and the skills that you need to teach your students. So let's get started with the worksheet. Again, please read these paragraphs on your own. It's going to be insightful to your teaching career. I'm going to start with question 1. For each figure below, write two fractions, one that indicate what part of the figure is shaded and one that indicates what part of the figure is unshaded. Question 1, this is an easy question. We have 1, 2, 3, 4 parts shaded out of a total of 9. This shaded part represents 4 out of 9, or 4/9. The top part is called the numerator, and the bottom part is called the denominator. And of course, this symbol in the middle is called the fraction bar. In this case, we have 4 pieces are shaded out of 9, so it's pronounced 4/9. Now, what part is not shaded? We have 1, 2, 3, 4, 5 pieces that are not shaded, so 5/9 of it is not shaded. In this example, we have 1, 2, 3 pieces shaded out of a total of 7 pieces, so this is 3/7. But what part is unshaded? Well, that's going to be 1, 2, 3, 4 out of 7. 4 pieces are unshaded. And question 3, we can do the same process. 1, 2, 3, 4, 5 pieces are shaded out of a total of 8 pieces. So this is 5/8 shaded. And how many are unshaded? Well, we have 1, 2, 3 pieces unshaded. This is 3 out of 8 pieces unshaded. So fractions represent what part of the whole we're referring to. We know 5/8 is shaded and 3/8 is unshaded. Now, of course, this is super easy for most of you. I understand that. But you're going to be teaching your students fractions, and you want to be able to understand the concept of what a fraction is. It represents a part of a whole. In question 4, we have 5 pieces are shaded out of 10. And the unshaded part is also 5/10. Now, what's the relationship between the shaded and unshaded part? We have the shaded part is 4/9. The unshaded part is 5/9. The shaded part is 3/7. The unshaded part is 4/7. The shaded part is 5/8. The unshaded part is 3/8. And in example 4, we have shaded and unshaded are both 5/10. Now, what's the relationship? If you look carefully, the relationship is the total of the numerator always adds up to the denominator. It adds up to one whole. So those are things that are important, and you might want to emphasize that to your students, that fractions are just part of the whole, and all of the parts have to add up to one whole. In question 5, we want to write 3 equivalent fractions to each of the following below. Now think about this as a fraction. I have a shaded figure here. This is equivalent to 1/2. But if I were to divide it into 4ths, this is equivalent to 2/4, but it represents the same part of the whole. So 1/4 is equivalent to 2/4. And I could do the same process here. 3/5 is also equivalent to 6 out of 10. Essentially what I'm doing is I'm multiplying the top and the bottom by 2. Now, a lot of instructors will mistakenly tell students what you do to the top, you do to the bottom. That does not make any sense at all. So never do that. The best way to explain this is to say we are multiplying by 1, because 2 over 2 represents 1. And 3/5 times 1 gives us a number that's equivalent to 3/5. So 6/10 is 3/5. We're just changing the denominator and numerator by multiplying by 1. And it doesn't affect the value. I could do the process again. Let's this time multiply 3/5 by 3/3. So this is also equivalent to 9/15. For 2/3, I can multiply the top and bottom by 2. Again, this is equivalent to a fraction that's equal to 1. 2/2 is equal to 1. And this produces 4/6. We can multiply the top and bottom by 3 now, and I get 6/9. For question 11, again I can multiply the top and bottom by 2, so 22/20 is equivalent to 11/10. We can multiply top and bottom by 3. This is 33/30. Continuing that same process, we'll multiply top and bottom by 2. I get 20/26. I could also multiply 10/13 by 3/3, and I get 3/39. So all of these are equivalent fractions to each other. You could multiply by any number that's equivalent to 1. Now in the direction it says write 3 equivalent fractions. I gave you 2 equivalent fractions. Please find the last equivalent fraction to 5, 6, 7, and 8 on your own. Just multiply by any fraction that's equivalent to 1. So you could use 2/2, 3/3, 4/4, 5/5, and so on. All of these fractions are equal to 1. So they don't change the value of the fraction. They just change how it looks. In question 9, let's find the missing number to make the two fractions in equivalent set. 3/7 equals 12 over something. Well, I need to figure out what do I need to multiply the top to get a 12. Well, that's got to be 4. And in order for this fraction to be equivalent, we need to use 4 on the bottom also. 7 times 4 is 28. So the missing part is 28. In question 10, I know I need to multiply 8 by 5 to get a 40. So we know we need to multiply by 5 on the top to end up with 25. So the missing number must be 5. In 11, I need to multiply by 5 to get a 30. So we'll need to multiply a 5 on the top to get 25. So our equivalent fraction is 25/30. So we're using the same strategy as the previous problem. We're multiplying by a number that's equal to 1. A very important concept, especially for students just getting into fractions. Again, we have another couple paragraphs that you should read on your own to get a general idea of the concept of fractions. In this case, we're talking about a mixed number. So we have 2 whole pieces added together and 3/5 of the piece. This represents 2 3/5. Now, if you count the individual pieces, this is 5/5. This is 5/5. And this is 3/5. The total, if I were to add all of these pieces, is 13/5. This is a great model to show students how an improper number is related to a mixed number. Now I want to use this method to show each mixed number below. We have 3 1/3. This is demonstrated by this picture. This represents 1 whole. This represents 1 whole. This represents another whole. And now we need 1/3. And so this is 1/3. This represents 3 1/3. For question 2, I can draw 1 whole and a half. This represents 1 1/2. Question 3, same process, but this time we have 7 parts. 1, 2, 3, 4, 5, 6, 7 parts, and we'll have to do that 4 times there. I want to show 4 and 2 7, so I have to shade all of this, all of this, all of this, all of this. That represents 4. Now 2 7ths, we'll just shade 2 out of 7 pieces. This represents 4 and 2 7ths. Before we do the next couple of questions, I want to ask you a question. How would we convert a mixed number to an improper number? Now, in order to do that, we have to figure out how many pieces there are. Now, if you look at this here, how many pieces do we have? Well, there's 3 of these, and each one has 3. So that's 3 times 3. So this part has 3 times 3 total of parts. What about over here? Over here we have 4, and each one has 7. So that's 4 times 7. So I can figure out how many pieces this is by multiplying the 4 times the 7. Same thing here, I can multiply the 3 times the 3 to figure out how many parts this is. And in the middle is the same situation. This is just a 1 times 2. So that's what I'm going to use to convert a mixed number into an improper number. In question 4, 5, and 6, I want to convert each mixed number to an improper fraction. Now the best way to visualize it is to look at our previous drawing and count all of the parts. But sometimes it takes too long to count the parts, so let's use a different trick. This trick is to multiply the 3 times 3 and then to add the 1. We know 3 and 1/3 is equivalent to 3 times 3 plus the 1 divided by the original denominator. And this can be simplified to 10 over 3. I could do the same process for question 5. We'll multiply, then add. 1 and 1/2 is equivalent to 1 times 2 plus 1 divided by 2. This can be simplified to 3 over 2. And for question 6, we'll do the same process. 4 times 7 plus the 2. 4 and 2 7ths is equal to 4 times 7 plus 2 over 7. And this simplifies to 30 over 7. In question 7, 8, 9, we want to convert this mixed number to an improper number. Now the best way to do this one is to use division. I'm going to divide 5 into 12 to figure out how many whole parts there are. And once we figure out how many whole parts, we can convert this to a mixed number. 5 goes into 12 twice. We have a remainder of 2. This represents the whole part, and this represents the fractional part. So in order to convert this to a mixed number, we'll write it accordingly. 12 over 5 equals 2 whole parts and 2/5 of a fraction left over. So we just have to use long division for these questions. 3 dividing into 28. 3 goes into 28 9 times. We have 3 times 9 is 27. Subtract, we have a remainder of 1. Again, this represents the whole part, and the 1 represents our fractional part of the whole. I can actually go in a clockwise fashion and write down my mixed number. 28 over 3 is 9 and 1/3. So that's a good way to teach students. You can say this is 9 and 1/3 by going clockwise. Same thing for number 7. It's the same process. We can say this is 2 and 2/5. For number 9, we can do the same strategy. Let's divide 15 into 97. Why don't you pause the video and try this one on your own? 15 goes into 97 6 times. 15 times 6 is 90. We have a remainder of 7. So this represents, going in a clockwise fashion, 97 over 15 is equivalent to 6 whole parts and 7/15. In this worksheet, I want to look at ordering fractions from the smallest to the greatest. Now there's several ways to do this, but let's focus on getting these to be equivalent fractions, and that's the previous worksheet. We know how to convert these to equivalent fractions by multiplying the top and bottom by the same number. It's very difficult to see who's the smallest or greatest because the denominators are different. So I want to get a common denominator. I want to find the LCD. Now if you look, 11, 8, 7, 11, we want to find a number that's divisible by all of these numbers. So we can actually look at 11. We can't break down 11, but I could break down 8. 8 is 2 times 2 times 2. 7 is prime, I can't break down 7, and I don't need to look at 11 again, I already have it here. To find the LCD, I want a number that divides into 11, 8, and 7. In order to be divisible by 11, I need an 11. In order to be divisible by 8, I need a 2, 2, 2. In order to be divisible by 7, I need a 7. So all of this multiplied together will get my LCD. And the LCD is 616, a really huge number. Now, a lot of people will make the mistake of saying, all you need to do is multiply 11, 8, 7, 11, but you would get a much larger number. It's better to get the lowest common denominator using this method of finding the LCD. And you're always welcome to look back at your previous notes on how to find the LCD. So now the idea is to get all of these to have the denominator of 616. Now what do I need to multiply 6 over 11 on the top and on the bottom to get a denominator of 616? Well, here's the trick. We know the LCD, when you multiply all of it out, gives you 616. This part is 11. So this part is what I need to multiply to get 616. And that's basically 8 times 7. So I need to multiply the top and the bottom by 8 times 7. And of course you could use a calculator to figure out what this is. This is going to give me 336 for the top. So 6 over 11 is equivalent to 336 over 616. We're going to also convert 1/8 to an equivalent fraction. Now what do we need to multiply 8 to get 616? Well, I know this part is 8. The 2 times 2 times 2 part is 8, so I need an 11 and 7. So we'll multiply 11 and 7 on the top and on the bottom to get our equivalent fraction. This is 77 over, well, I know the bottom has to be 616 because that's all of the numbers in the LCD. We'll do the same thing for 5/7. We'll multiply the top and bottom by a number that's equivalent to 1. This is 7, so we'll need an 11 and an 8. This gives me 440 for the top, and on the bottom, we know it's 616 because that's all the numbers in the LCD. One more time, we have 3 11ths, and we have to multiply the top and bottom by a number. We know the denominator has to be 616, and I know this is 8 times 7. This gives me 168 over 616. Now we could arrange it from smallest to greatest. If you look at the numerator, this one's the smallest, 1/8. So we have 1/8 is the smallest. The next smallest number in the numerator is this number, 3 11ths. Then we have 6 11ths. And then finally, we have 5/7. And so we have the numbers from smallest to greatest. For question 2, I again want to find the LCD. So we'll have to break down 10. 10 is equivalent to 2 times 5. 9 is equivalent to 3 times 3. 3 is just 3. 10, we don't need that anymore. We already mentioned it earlier. So I need to be divisible by 10. Well, then I need a 2 times 5 in my number. I need to be divisible by 9. Well, I need 3 times 3 in my number. I need to be divisible by 3. Well, we have plenty of 3's. So the LCD is going to be the product of all of these numbers, and this should give you 90. The LCD is 90. Now we need to multiply 1/10 by something over something to give us a 90 in the denominator. Well, that's got to be 9 on the top and 9 on the bottom. So this is 9 over 90 is equivalent to 1/10. And again, I need to get the 90 on the bottom. What times 9 gives us 90? Well, that's 10. I need to multiply 10 on top as well. So this is equivalent to 20 over 90. 1/3. I need to multiply the top and bottom again by a number to get the denominator being 90. This one's a little bit more difficult, but you can look, there's a 3 here, so we need a 2 times 5 times 3. I know that's 30, so that's 30 here on the top and on the bottom. So we'll say 1/3 is equivalent to 30 over 90. 7/10. I can multiply the top and bottom by 9. That gives us 63 over 90. Now we could arrange it from smallest to biggest. What's the smallest number? Well, that's going to be 1/10. The next biggest would be 2/9. Then we have 1/3. And finally 7/10. This is the fractions from smallest to biggest. Let's do one more example together, but I want you to finish the rest of this worksheet. It's not too difficult to do, but try it on your own. Finish the rest of this worksheet on your own. And a good way to check your work is to use a calculator and convert each of these to a decimal. Then you'll know for a fact that it is from smallest to biggest. So again, you could check your work with a calculator. You can say, oh, this is 0.10, and then use a calculator to divide 2/9. That's about 0.22222. You could do it for 1/3, and that's a good way to check, oh yeah, it is from smallest to biggest. Using a calculator, you could always double check your work. Let's do one more together. Let's find the LCD. I know 7 is prime, can't break that down. 6 is 2 times 3. 8 is 2 times 2 times 2. 11 is prime, cannot break that down. I need to be divisible by 7, we'll need a 7. I need to be divisible by 6, so we'll need a 2 and a 3. I need to be divisible by 8, so we'll need just 2 more 2's because we have a 2 from the previous problem. And then we need an 11. Wow, this is going to be a huge LCD. Let's multiply it all out. My LCD is 1,848, an incredible 1,848. Now let's convert 1/7 to an equivalent fraction. What do we need to multiply the top and bottom so that the denominator is 848? What do I need to multiply by 7 to get 1,848? Well, I need this part. I know 7 times this number equals 1,848. So that's what we need. We need all of this to multiply to 7 to get our denominator that we want. And that's 264. We need to multiply the top and bottom by 264. Where did I get 264? I multiply all of this out to find that number. And of course 264 times 1 is 264. Let's look at 5 over 6. What do I need to multiply the top and bottom to get a denominator of 1,848? Now you could look at 6, and 6 is right here. So we need a 7 times 2 times 2 times 11, and I can use a calculator to figure out what that is. 7 times 2 times 2 times 11 gives me 308. So we have 308 on the bottom, and I can multiply that with 5. 308 on the top times 5 is 1,540. Now, looking at these primes, we can figure out the number that we need. We could also use division. For example, 4 over 8, I can figure out what I need to multiply the top and bottom by looking at division. I can actually do 1,848 divided by 8. 1,848 divided by 8 gives me 231. So I know multiplication, 8 times 231. So I know 8 times 231 would give me 1,848. So we can also use division to figure out what this missing number is. And of course the bottom and the top have to be the same because this is equivalent to 1 again. 4 times 231 gives me 924. 6 over 11, I need to figure out what we need to multiply the top and the bottom to get our denominator of 148. 6 over 11, I need to figure out what I need to multiply to the top and to the bottom, so my denominator is 1,848. We can use our calculator, divide 1,848 by 11, and I get 168. 168 is the number we need to multiply by 11 to get 1,848. So we'll use that on the top, and that gives me 1,008. Now I can see who's the smallest. The smallest is... Now I can check to see who's the smallest fraction. This number is the smallest number. So we're going to say 1/7 is the smallest fraction. The next smallest is this number. So the next fraction is 4/8. And then we have this one's third. So we have 6/11. And then finally 5 over 6 must be the largest fraction. And that's it. That's how we do these questions. You get the common denominator first. Then you can clearly tell by looking at the numerator who's the smallest and who's the biggest.